To end with pollution, don't forget you have to go over all the solutions, and if you have questions, you ask me. But there's a lot of changes being made. There's a lot of regulations. And so, the strange part of regulations is, and we're going to talk about acts again, there's a certain amount of emissions you can produce in a certain area, yet you can pay to emit more, and you kind of like exchange emitting rights with other people for money, which is very weird, but technically not good because then you're emitting more in a specific area. But look at what's happened since our power plants have been rebuilt or redesigned. They decreased SO2 and NOx and particulate matter emissions. And that's about it. New cars obviously have better emission standards and better efficiency standards. So all of those changes will lead to less, hopefully. And are we at a point where that's going to make a difference is what we have yet to see. So, okay, climate. Several factors affect climate. What are they? Distance from the sun. Distance from the sun is perfect. Just the sun in general, actually. Whoops. Volcanic activity, which was what he said. And where's my sun? At the top. Distance from the equator, my bad. And why do I feel like that's here? Solar activity? There. What else? Look at these pictures. What do you think I'm referencing here? Currents, what kind? Oceanic and wind. Good. And then believe it or not, where you're located, obviously, makes a big difference. I don't know why it's history of Earth's atmosphere. It's really climate history. Over the past 4.7 billion years, the climate has been altered by what things? Humans, definitely. What do humans do to alter it? Well, that's not human. There's changes in solar input, volcanic emissions, movement of the continents, and then impact of meteors. Okay, so humans is not even here. It's coming in the next slide. Yeah. Humans definitely have affected climate, but these are natural occurrence or natural changes, right? And then I want you to know that there is these periods, and we've got the glacial period, which is the ice age, and then interglacial period, which is between ice ages. And this is where a lot of the debate originally, when the issue of, not the issue, awareness of our Earth's climate became national. There was a serious debate. And it's because people think that the interglacial periods is normal for the warming to occur, okay? And they're not wrong. So keep that in mind when we look at the graphs, because you'll see that those patterns are very natural, but then you'll see what's happening within the last 50 years is completely above the normal of natural temperatures or climate throughout the history of the world. So there's an overwhelming scientific consensus that Earth's atmosphere is warming rapidly and mostly because of human activities. So that last slide was what's affecting climate naturally, what's affecting climate because of us. That's what the focus of the rest of this unit is about. And here's a picture of climate over the past 10,000 years, 1,000 years, or whatever. But do you see what happened right in this period right here? What do you see throughout every one of these graphs? Rise and fall, and rise and fall, and rise and fall. Here's the 1,000 years, okay? And you'll see that what happened at the end? It spiked beyond the natural pattern of the rise and fall, rise and fall. Same thing here, rise and fall. I mean, we draw a line and then look at this, way above. And when you see the inconvenient truth, the way he actually gets like on a reasoning for doubting is how we actually determine Earth's history or climate in the history. Because we're using, data from now that we collect based on things we find to say, oh, this is what the climate was 100,000 years ago. So, there's another reason for the debate. So any idea how we come up with these things?
We test the carbon date.
So remains of organisms, And they focus on plankton, insects, and droppings. And they also do what? Look at my pictures. Oh, well, you also said this. Rock fossils, so dating of carbon. Air and glaciers. They actually remove what's called cores, and you want to know that word, okay? In glaciers. And there's a picture right here. So, I mean, I could zoom in. And then they backdate levels of carbon dioxide, and they compare them to the atmosphere because they're supposed to be balanced, yes? And then temperatures taken since 1861 because that's as far back as we can say we've been tracking. And look at this alone. Do you see that? Okay. All right, so our climate actually depends on something for us to be able to live, because if not, it would actually be way beyond living conditions. It would be too cold. Anybody know what that is? Atmosphere. Nope. Well, ozone is one of them, actually. Okay, so the sun normally, yes, greenhouse gas is good. And the sun is technically right because the sun emits rays that come down to Earth and then are re-radiated back into space. But because of the greenhouse gases, these rays then come down as heat back to Earth to warm it and let us live here. Now, I'm going to explain that whole process again because you have to know that entire process. So in this diagram, let me see if I have another one before I do it. No. So we're going to color this diagram, okay? So, and we're going to add words to it. So this is sun, and the sun produces ultraviolet rays or radiation. Let's do that, which another word can be rays, okay? So these rays right here that come down, I'm going to make them red. And I'm going to label them UV rays. Okay? When these rays come down to Earth, they're reflected back as heat. So I'll make these, I guess, I'll leave them yellow. Even though heat should have been red, right? Well, orange. I don't know if you're going to be able to tell the difference, but let's see. Okay, it worked.
Good morning, Maverick. The Lincoln
Infrared.
schedule for Tuesday, January 12th has been moved from Ms. Chris Fletcher's room to the Student Center and will occur immediately after Link Crew's yearbook photo. Attention sophomores interested in attending the Antioch retreat that is February 24th to the 26th
I wasn't recording.
on Wednesday, January 13th at 6:30 a.m.
Oh, yeah. So the infrared rays are reflected out. So here's another one. But then you've got a stream of gases. So here's an example of the gases right here. Water vapor being one of them. So let's say we could label this cloud here greenhouse gas. And I'll change the color to green for greenhouse gas. These greenhouse gas cause the infrared rays to be radiated back down. So they go up, and technically they're supposed to go into space, yet they come back here and they warm up Earth. So to go over it again, you've got UV rays coming down from Earth. That's my red line. They're reflected as infrared heat rays or IR rays that technically will go into space. But because we've got a layer of gases in the troposphere, when these infrared rays are reflected back out, they are re-radiated back down as heat, which warm up Earth. And then I'm going to cover some of these greenhouse gases in a minute.